Now then, take two with hopefully better sound. So it's the electrophilic addition mechanism, and we're going to react bromine with ethene. So there's an ethene molecule. Carbon-carbon double bond, functional group. It's where the reaction will take place, the reactive part of the molecule. Two pairs of electrons in a double bond compared to one pair of electrons in a single bond. So the carbon-carbon double bond, we would say, is a region of high electron density. We've got a bromine molecule, it's miles away from the carbon-carbon double bond, and so it's non-polar because bromine and bromine have the same electronegativity. However, if we move it a bit closer, then the electron density here will repel the electron pair in this bond here down towards this bromine at the bottom, and we end up with a dipole. We've got a slightly positive part, a slightly negative part, because remember the electron pair is closer to the bottom bromine. And because of that, this difference in charge, negative, slightly positive, is an attraction between a pair of electrons in this bond and this bromine. So we show that as a curly arrow. So a pair of electrons move towards the bromine that's slightly positive. Because the electron pair is much closer than it was before, then the pair of electrons in this bond is pushed completely or repelled completely onto the bottom bromine, and that actually breaks the bond, and we call that type of bond breaking heterolytic fission. Heterolytic, hetero means different. The bromine at the bottom has actually got both of the electrons from the bond. The bromine at the top doesn't get any, so that's different. No electrons from the bond, and that gets both of the electrons from the bond. So heterolytic fission. Okay, so what does that produce? It produces this. So there's the pair of electrons that have come out to this bromine. So that effectively is that bond there. So the carbon on the right, this carbon here, has still got 4 electrons of itself, from itself around it. Okay, so this carbon here has got 1, 2, 3, 4 electrons. 1, 2, 3, 4. So this doesn't have any charge. This carbon, however, has got 1, 2, 3 electrons around it. 1, 2, 3, 4. So it's lost an electron because its electron is in this new bond here. So this is positively charged, and we call this a carbocation and not carbocation. That's just going to make me laugh. Okay? Right, the bromine is got both of the electrons, remember, from the bond, so effectively it's gained 1 electron, one more than it had originally. So let's say that one there was the one on this side of the bond, so this one here is the new electron that's come from this bromine, and so it's a negatively charged ion, so it's a bromide ion. And now you can probably see what's going to happen next. This pair of electrons, which is negative, is going to be attracted to that plus, and we draw a curly arrow like that, and that makes the product. I'll just give you a couple of seconds to work out the name of that before I tell you. That's right, it's 1,2-dibromoethane. Brilliant. Why is it called electrophilic addition? It's because it involves an electrophile. Electrophiles are electron pair acceptors. So what's accepting a pair of electrons at the start? It's this Br at the top here. So that's the electrophile. Why is it addition? Because 2 reactants make 1 product. Remember the Spice Girls song? I won't sing it. 2 become 1. So I hope that's helpful and sounds better than the first one. Cheers.